Hi, I'm Steve Sabat from the University of British Columbia. I won't take much time, but after that wonderful introduction, I feel constrained to say I'm at sort of the opposite end of the spectrum from Eric, in that I have never really had any contact with Howard Stein in person in my life. But I am like any number of philosophers whom I've met from time to time, who all have the same experience of waking up in the middle of the night in a cold sweat with an image of Howard Stein looking at one of our papers, sadly shaking seeing him sadly shaking his head.
See, for me, that wasn't a dream. That was a daily occurrence.
Has it come to this? Has it come to this? And then the next day we tried to make our drafts a little bit better. It's a pleasure for me to introduce first the two philosophers who do great work on a subject I'm particularly interested in, time. This is Oliver Pooley from University of Oxford. Oliver, on his website, assures us that time does not pass, and I take it in his talk this morning he's going to clear out a couple of other details about time.
So, has it come to this? Yes. It has, I'm afraid. Okay, well, it's a complete thrill and privilege to be here. Like Steve, I have had no personal contact with Howard Stein at all, but I am in awe of his work. Two bits of it I'm particularly familiar with. So the material I'm going to be talking about today, his response to arguments by Hilary Putnam, Wim Rietvink, and Nicholas Maxwell on the notion of becoming in relativity, but also his work on particularly Newtonian space-time structure. And I have spent a lot of time thinking about those, and in particular his contributions to that literature. And I obviously wasn't familiar with lots of the anecdotes that Eric gave us, but they ring completely true with what comes through in his papers. Okay, so my topic, Stein's notion of becoming, the metaphysics of time. Right, okay. So here's an outline. By the way, I'm going to apologize for these slides. I'm not making any excuses, I'm just giving you a warning. They were prepared in slightly unusual circumstances, and that means that there are various things that I would like to say which are not on them. And for that reason, there's a whiteboard which I may end up using. But it also means if at any stage I've just become entirely incomprehensible, please interrupt me, and let's try and get something out of this particular session. Okay. So here is the outline of what I'm going to talk about. The talk comes in two parts, like the three parts here. The first part is focusing on Howard's work, the arguments he's responding to and his response to them, but also trying to connect that to distinctions that have been made in the metaphysical literature on the philosophy of time. And in particular, I think was labouring under a failure to understand something, and therefore I was putting Stein's proposal and in the wrong box for many years. And so one of the things I want to do is say why the view I had was wrong, and explain what I think is being proposed. The upshot of that exercise will be that there's this particular metaphysical view, which is a view that I think Stein himself would not be very hospitable to, but I think it's what you get if you basically take his attitude but are more open to metaphysics than he is. And I want to consider that view, or those families of view, in trying to make sense of these two things, and in particular trying to make sense of what some physicists have been saying recently about causal set theory. So, branching spacetimes is a framework proposed by Noel Belknap and then worked on by various collaborators. And in the sort of seminal paper from 1992 where Noel Belknap introduces this, he explicitly says right near the beginning of the paper that his inspiration was Howard Stein's work that I'll be discussing. And so it's more that I want to relate these two and see how branching spacetimes both gives you a way of thinking about the metaphysical view that I'm going to extract from Howard Stein's papers. Yeah, that's basically it. And then we move on to causal set theory, where various physicists have claimed that we can make sense of becoming in a way that does not presuppose a kind of universal global now that moves up through space-time as time passes. And you might wonder whether what branching spacetimes is supposed to give you is exactly that. So, as well, a non-B theoretic view, I'll say in a moment what I mean by B theoretic view of time, a non-B theoretic view of time, but one that doesn't violate relativity by introducing some global now. So we'll be extracting some metaphysics from this and then seeing whether we can be more rigorous about the type of claims made in these contexts. And the upshot will be slightly disappointing. So I think there's a kind of way of trying to make sense of what the causal set theory advocates of becoming mean, but I don't think it's very attractive in the end. Okay, so moving on to this first section, the revisiting Howard's responses to the arguments of Putnam, Reedick and Maxwell, and extracting metaphysics. In working out what to say, I found it difficult to decide whether to kind of go with the metaphysics first, and then start talking about the details of the papers, or the other way around. Neither seemed to work very well, and so I'm kind of not doing either. It's going to be a rag bag, I'm afraid. Okay. So let me start by giving you the arguments, or not giving you the arguments, but giving you my version of the headline conclusions of each of the arguments that Stein then criticizes. So according to Wim Reedick in this paper from 1966, a very short paper, he claims that relativity implies determinism. And in particular, he's got various claims in this paper, but there's this claim that if we're considering a particular agent, well, we shouldn't perhaps call them an agent, a particular observer in space-time W1, and we're considering a particular event P that's to their absolute future, then, for reasons that we'll review very quickly in a minute, he claims that someone else can prove that W1 could do nothing at all to prevent event P in his absolute future. And that's why he says that relativity implies determinism. So we'll be looking in a bit more detail at what that claim is. So that's Reedick's argument. Hilary Putnam, in a perhaps much better known paper from the same time, 1967, made the following claims in his argument that relativity rules out certain views of time. So one is the claim that you get from relativity that future events are already real. So in particular, he's considering a view of time initially where you're thinking that the future is not real, it doesn't exist yet. The past is not real, only the present is real, and he says that's incompatible with relativity. You have to conclude that the future is already real. And he also has this claim considering Aristotle's problem about whether there will be a sea battle in the future, that statements about future contingents, all statements about future contingents already have a determinate truth value. So that's ruling out the view that, at least for some statements about the future, there's no matter of fact about whether they're true or false. So for example, take the sentence uttered here right now that there will be a sea battle tomorrow. On some views, that's neither true nor false, and Putnam claims given relativity, you have to conclude that it's either true or false already. Maxwell's claim is that relativity is incompatible with what he calls ontological probabilism. Okay. So the point of putting these all up is to indicate that although, as Stein is absolutely right to point out, they all are based on basically the same geometrical facts, and although there's a sense in which they're all arguing for very closely related things, there are important differences in their stated conclusions. But Stein's summary is this. So this is from his 1968 paper. So obviously this isn't talking about Maxwell, whose paper written in the mid-80s was kind of unaware of all this literature, and that's what provoked Stein into revisiting the topic in 1991. So according to Stein, the two articles cited draw their conclusions by means of the same basic argument, a very simple and in a certain geometrical sense a correct one, but an argument in both cases seriously misapplied. And in terms of the conclusion that he attributes to both Reed-Deek and Putnam, the central conclusion of both papers then is that special relativity is incompatible with the notion of temporal evolution, as in some sense a becoming real or a becoming determinate of what is not yet real or determinate. Now this is interesting because I think in Putnam's paper and in Reed-Deek's paper at least, I'm not sure the word becoming or temporal evolution is used. So this is a sort of odd, or well, not odd. It's sort of seeing in both of these arguments something that isn't given by the people giving the arguments explicitly as their own conclusions. So I don't disagree that this is the heart of the issue, but it's not something that's coming straight from the papers he's criticising explicitly. So yes, Stein is, in these papers, is known, and here is the core proposal, putting forward the following claim that there's a notion of becoming compatible with relativity, and this is it. So the basic idea is that for an event, a man considering, for example, at a space-time point A, those events and only those have already become real or determinate, which occur at points in the topological closure of the point of A. So the idea is that for each point A, what has become as of that point is just those events in and on the past light cone of that point. And I say this is the relativistic proposal. People familiar with the paper will know that he actually first introduces this in the context, well, this, he says, is what you would say in a pre-relativistic context, and his point is that you can take it over unaltered into a relativistic context. And his point is that, so there is real becoming in relativity, and nothing that Putnam and Reed-Deek and later Maxwell say undermines this claim, the core of this claim, that we can think that there's real becoming in relativity in this sense. So at this point, I'm hoping that you're all slightly confused, not just because of my delivery. We've had various statements of claims put forward by Putnam and others. We've got Stein claiming, no, becoming is compatible with relativity. Here's a notion that can rightly be taken what we mean by becoming, and he shows how it's compatible with relativity. And he points out that the things adduced by Putnam and others do not undermine that. But you might think, well, somehow this debate doesn't look like it's been engaged in the most kind of flat-footed and straightforward ways. And this was my view, right? So on the one hand, there's Putnam basically arguing presentism is incompatible with relativity if you think that what's real in the presentist sense only... So according to the presentist, is space-time, right? And according to the presentist, some proper subset of what's represented here is what there is. So reality corresponds to some proper subregion of this diagram. The rest of the diagram represents what was the case, but is no longer, what will be the case, but isn't yet. But this line represents what is actually the case now. But not just actually the case now, actually the case full stop. This is an issue that I'll come back to. And Putnam is basically saying, if you think that the region that corresponds to what's real, should be definable in terms of the space-time structure of relativity, that it's not something that you add on in addition to the structure of the space-time described by relativity, then it turns out the only possibilities for a region like this, given certain constraints which I'll start to consider, are either a single point or the whole of space-time. Now, what's that got to do with becoming? Okay, so we'll come back to Putnam in a second. Let me first say something about Reed-Deake's argument, which is worse, but simpler, and we can, so the basic point is this, right? We're considering two observers, A and B, and Reed-Deake says consider observer A at the event A0. For that observer, this event B0 in the history of B is happening right now. So these aren't Reed-Deake's words, but this is the effect of it. And for B0, for B at B0, given his state of motion, this event P is present for B, or to make the point more dramatically, we really should have considered an event to the absolute future of A0, but in the coordinate past, but before the simultaneity surface for B that intersects B0. And then Reed-Deake says the following thing. So, having considered this kind of construction, he concludes each event is determined. Why? It is already past for someone in our now. So here is us, here's our now, here's someone in our now, and for that person, any event you like in our absolute future is going to be in the past for them. So what follows from that? So why should we think that an event is determined if it's already in the past for someone in our now? Well, considering a slightly different construction, Reed-Deake says this observer B can prove at a certain moment that A could not possibly have influenced this event P in an arbitrary way at any moment when P was still future for A. So consider any event to our future. Reed-Deake's claim is that it follows from relativity that there's not that event is not influenced by me. So in a way, this looks like the opposite of determinism, right? We seem to be able to argue for any event, for any two events, one in the absolute future of the other, it's impossible for this event, or for an agent situated at this event, to have influenced the event that we're considering in their absolute future. You might have thought determinism involved events in the future all being the result of the causal influence of events earlier. So there's something strange going on here. Well, let me make two observations about this argument. So first, one that occurred to me as I was revisiting these things today, but then to give Stein's key observation. So, what's it taking for B to be able to prove that A could not possibly have influenced event P? So, it's basically the case that at the crucial time, B regards the event P as being in their past. And they do that at a time which is either to the past of or simultaneous with, according to A's coordinate system, the event in question where we're asking of it, could it have influenced P? Now, when they consider things in that way and think P as either in their present or in their past, they think of this event as even further in their past. So it's strange to think that when viewing the world in that way, they conclude that A at A0 could not have influenced P. Because when they view the world in that way and think P is determined because it's in my past, they also think that A0 is in their past and even further in the past. And so surely you would think able to have been the cause or to have influenced the event P. So that's that claim there. At any moment when P judges P to be present, they judge all of the moments of A's world line that are in the absolute past of P to be yet further in the past. And that would seem to be compatible with A's having brought about P by some action at A0, and for all that's been said, having had the ability to do otherwise. But all of this is to go along with Reed-Deak, that some event being in your past in this coordinate sense relative to the standard way of setting up inertial coordinates for this time axis has got anything to do with something really being in your past. And this is the point that Stein is making here. A time coordinate is not time. So neither A0 nor P is in any sense, in any physically significant sense, present or past for B at B0, for neither has already become for B at B0. So the point is, this argument is trying to get conclusions from the fact that P for B at B0 is past and therefore must be regarded as determinate. And of course that is exactly what Stein rejects. Only those things in B's causal past, in this coordinate independent notion of past that relativity gives us, should be thought of as already determined relative to B0. Okay. So let's move on to Putnam. By the way, what's the time? Because I didn't. How long do I have?
20 minutes in, so about 45 minutes.
Okay, so it's 15:15. I should stop. Yeah. Good. Okay, so here is the key, controversial, much criticised by Stein claim of Putnam in this paper. So he has a various arguments to the effect that thinking of just what exists now as real is incompatible with relativity. And one of the things he seeks to try and derive this from relativity is this commitment. If it is the case that all and only things that stand in a certain relation are to me now are real, and you now are one of those things, then it should be the case that all and only things that stand in that very relation are to you now are real. Okay. So here are a couple of revealing things that Stein says about that particular principle. Why is the notion real assumed on the one hand to be characterized by a relation R, whose reference is clearly something like an event or space-time point, or observer at a given time, while it itself, on the other hand, is treated as a simple predicate unqualified by any such reference? And then here we have a very, okay, so that's the claim. So Stein thinks, really if you're trying to get to the heart of the way Putnam's arguing, here's what you should do. You reformulate the principles in the following way. First, the notion real for the arguments of the paper must be represented as a relation X is real for Y. So we've thrown out is real, full stop, monadic predicate, and replaced it with this real for relation. Okay, so that's one revealing an important claim of Stein's. Here's another claim. So at some point in the paper, Putnam explicitly considers taking as what's real, or what is determined. So this is when he's moved on to consider whether things have a truth value. The proposal that Stein puts forward, namely only statements about things, so putting it in terms of statements rather than events, statements about happenings in the past light code of a point have determinate truth values if they're about contingent matters. Statements about events in the elsewhere or in the future, if they're contingent, do not have truth values as of that point. And Putnam says, well, what about doing that? And his answer is that the move flagrantly violates the idea that there are no privileged observers. Why should a statement's having or not having a truth value depend upon the relation of events referred to in the statement to just one special human being, me? And Stein answers, right? The answer is that having or not having a truth value in this question must be understood classically to mean at a given time. So even in the classical context, there's relativity of truth value to some index. In the classical case, it's a time, a global instant. Now, there just aren't times in relativity, and the appropriate things to relativize to, according to Stein, are space-time points, and so you end up with exactly his proposing. Okay, so, whoops. Okay. So I think what these claims of Putnam reveal is that he is implicitly assuming that if there's a sense in which reality, or what's determinate, is less than all of the events in space-time, then that is not something that holds only as of me now, is meant to be, according to the person who's putting forward this non-theoretic view of time, something that's meant to be true full stop. So although there's a sense in which it's true now that there will be a sea battle, so it's true now that there was a sea battle yesterday, and some other time it might have been neither true nor false that there would be or will be a sea battle then, those truths follow, on this way of thinking about a non-B theory view of time, from the fact that there are these truths full stop. So what is true now is what is true full stop according to this view, but what is true full stop changes. So this is something that really should have been on a slide, and I apologize. So let me give you the way I'm dividing things up. So let's make, so this isn't going to map onto things perfectly, but so on this axis we have the choice between tense reductionism and tense non-reductionism. And then we can have monadic truth, whether there's some notion of truth simpliciter and not merely truth relative to a time or relative to a space-time point. And here we have relative truth. So according to this, the views in this column, you can talk about what is true as of some time, but if you're living in this column, you think that's not because there's some monadic truth, some truth about how things are from no point of view, from which one can derive that certain things can be said to be true as of some time. On this column, there are just things that are true as of some time, and that's rock bottom, right? Now, the standard A theory that's being implicitly assumed by Putnam, and that's why he's talking about real as a monadic predicate and not considering a real correlation, is this combination of there being some truth simpliciter, how things are absolutely speaking, not from any point of view, where various different points of view are on a par, with tense non-reductionism. So this is standard A theory. So presentism, perhaps the growing block view, perhaps, the growing block view and the moving spotlight are interesting, and that's what I'll get onto at the very end of the talk. Here we've got B theory, right? This is the view of time according to which rock bottom how things are is how things are from no point of view. So I give you a complete description of how space-time is, and that's a kind of complete description of the world. And from it you can derive that various things are true as of certain points within space-time, that there are various perspectival truths. But the perspectival truths follow from relational facts and facts that are true from no point of view. But then we've got these two possibilities. And what I'm saying, this kind of difference of opinion between Stein and Putnam is revealing, is that Stein should be put in this camp, or at least he's not, he may say, well, there is this monadic way of talking, there are monadic truths about history as a whole. There's also truth about how things are from from particular points of view, but it's not the case that this is somehow more fundamental and that you derive this from this. So let me just leave these unfilled in for the second.
Ollie,
Yeah.
so you're talking about truth here, but earlier the words were like reality or determinateness, but those are all kind of the same thing.
I'm just going to duck that for now.
Okay.
But good point.
Okay.
Yeah, yeah. Okay. So let's go back to the principle of no privileged observers. So one thing that gets brought up in the paper is whether Putnam's doing something illegitimate to assume that it's effectively symmetric as well as being transitive. So, well, first of all, I mean, notice that literally as this is phrased, R needn't be, I mean, this principle could be true vacuously if it's not the case that all and only things that stand in a certain relation are to me now are real, where R has to be definable in terms of Minkowski space-time structure. Maybe there's a fact about which things are real, full stop, that those things make up the less of the full contents of space-time, according to the block universe description of it, but there just is no relation R definable in Minkowski space-time that all and only things stand in to me, right? So this could be vacuously satisfied. So really what we need to add is that there is some relation that gives the content of, or somehow explains or somehow illuminates what it is and why those things are exactly the real things. It should be definable in terms of Minkowski space-time structure. But let's suppose you think that. Then what we have is that the principle says, for all events that are real, this relation restricted to those things, so we're considering a relation on all events whatever, and that may include some things which are not real according to the A theorist. Namely, I mean, this might be perplexing, but let me suggest the following way of thinking about it. And that's, I think it's useful to consider the modal analogy. So I think often we're much happier to think that what exists, full stop, is what actually exists. If something doesn't actually exist, then it just doesn't exist. But of course, we think that there are things that might have existed but didn't, unless you're Tim Williamson, and that there are things that, some of the things that do exist might not have, right? So in a similar way, when we consider our space-time representation of history, and say of certain events and objects that are located at these times, as the B theorist would say it, that only those things are real, these things are not things that exist but don't exist. They are just representations that it will be the case that something that doesn't exist will exist. That doesn't actually exist. That there will be something that doesn't exist. Right? So there are ways of making these claims within the context of tense operators where you're not committing yourself to these objects that exist that would seem to be existing at other times according to this way of speaking. So that was meant to clarify it, but by the end so think of this as the actual world and think of these as non-actual possible worlds. Or, inhabitants of non-actual possible worlds that don't exist, right? Hopefully that you may be happier with this than this particular version of the A theory. Now, the point is that R, the relation we're considering, is defined on this bigger space. And all that the principle of no privileged observers requires is that restricted to the real, it's the universal relation. But that's compatible with R looking something like this. So, there could be an object here, and I stand in the relation to it, but it doesn't stand in that relation to me. And now we've got a symmetric, non-transitive relation, compatible with the principle of no privileged observers. So what you really need is, of course, that although this is how these are the real things, we also think that what this represents is how things will be and how things were. So these things will be real, and then these things will be real as time passes. So there's something extra you need to think that this is forcing you to think that it's, and then you want exactly that as time passes and the things that are real change, at that time, exactly all of the things that then exist stand in the relation to each other. So effectively, you're dividing up events into equivalence classes. Okay. So what about having real 4 as transitive but not symmetric? So a change of the no privileged observers principle which would rule that out, or rule out it being definable in Minkowski spacetime, I think, would be the claim that there is at least one thing, or one event, not identical to me now, such that everything that's real stands in that relation to it. So it's a kind of, there's got to be at least something other than me that bears the relation to what's real, to exactly the same relation to what's real as I do. So there may be some things that are real that don't stand. So the idea is that there may be things which are real because they have happened, that are no longer happening. And it's not true that everything that's real stands in the relation R to them, because there are some things which happened after them. And these things don't stand in their relation to the ones in the past. But there's a whole group of things, according to classical physics, if you take in the past of as the relation, such that everything is it. So this guy and this guy is such that everything that's real stand in that relation to that one and that one. So this one's not a privileged observer. All of these are privileged observers relative to the things that have happened, that are in the past. But the things in the present, they're privileged by being in the present, but there's a whole group of them. Now, why would you want that? Why would you think it's not okay just to say, no, there is a privileged person. There is a privileged event right at the apex of the collection of things in space-time that are real? Well, it's precisely if you're thinking of what's required in this standard A-theory way, where this is what's real, what's true about what has happened or will happen, or might be such that it will be true that it has happened, is true full stop, i.e. just in case you're a standard A theorist. If you say, well, that's what's true as of this point, but as of this point, it's this point that's special, there's no longer the pressure to say there's a problem in having a privileged observer. So what we're seeing is that in saying, look, there's just no problem, Stein's thinking of things in exactly this way, and not thinking of things in the standard A theory way. Okay, so I'll come back to these issues in a second, although actually I've got 6 minutes or so. Another collection of things that come up in these papers are confusions about determinism. And let me quickly draw some distinctions which are quite familiar now. It seems we might have indeterminism without indeterminateness. So maybe the B theorist is right. The truth about the world can be given by some space-time model. But the space-time model is a solution of a theory that has the following property. Right? If I give you the complete description of space-time up to some time and give you the laws that this is a model of, it doesn't fix what this bit of space-time looks like. So this is a standard way of thinking about determinism that is discussed by David Lewis and John Ehrman. I think both of them are kind of developing a way of thinking about it due to Richard Montague. So here, as of this point, there's a fact of the matter about the future. It's just that it's a fact of the matter that isn't fixed logically by telling you about this part of space-time and giving you the laws. So it's an indeterministic world, but the future is determinate. There is only one future, and nothing about it is indeterminate. Okay, that's to be contrasted with a view according to which, as of this point, it's not just that in the sense I've just described, the laws don't fix the future. The future just, there's no matter of fact about what the future is. So that's the notion of indeterminateness, contrasted with indeterminism. Now Maxwell draws exactly, basically his notion of predictive probabilism is this notion of determinism that's compatible with a single history and a determinate future. But he says, that's compatible with relativity. I don't deny that. What's incompatible with relativity is what he calls ontological probabilism, which is a view that precisely, as of now, there's more than one possible future, and they're all equally real. There's no sense in which one amongst them is the actual future, although not fixed by the laws. There is no single future. Or you might say there is a single future, but it's not determinate what occurs at various spatial temporal locations in that future as of the earlier time. So that's ontological probabilism. And Maxwell's claim is that's incompatible with relativity. So a couple of Stein's misgivings about this way of setting things up. So he says it is seriously questionable whether the view that the future is determined, but in principle unpredictable. So in my jargon, the future is determinate. There are facts of the matter about whether there will be a sea battle. It's not fixed by the laws, and therefore not predictable. It's seriously questionable whether that view, as a view about the world, and not merely as a manner of speaking, is different from the view that events are indeterminate until they have occurred. So he basically is saying he's skeptical of the very distinction that I think is important for understanding Maxwell at least. Now of course he notes that even if your Lorentz invariant theory is deterministic as in exactly this sense, you know, when I give you the past given the laws, that fixes the future relative to some space-like slice through the model. It's still the case. Good. It's still the case that as of a particular point in time, as of a particular point in that space-time, you've got serious unpredictability because I can only know things that can causally influence me. I can only have evidence for how space-time is based on this past light cone, and it's always possible that there's some event that lies outside that is going to influence anything in my immediate future. So he makes this nice point that, you know, it's kind of exactly as a matter of principle, there's this unpredictability in any relativistic world. Okay. Having said that, though, in responding to Maxwell, where Maxwell makes this explicit distinction between determinism in this sense and this ontological indeterminism, Stein claims, I have argued that special relativity is perfectly compatible with ontological probabilism. And then, of course, we've got his claim about becoming. And it seems to me that if you're saying this is incompatible with ontological probabilism, then you're not allowing a purely deflationary reading of this, which is how I used to think about it, compatible with the B theory. You're saying that when it's true, as of this point, that there are events here which have not yet become real, they're not yet determinate, it's not merely the case that there's some fact of the matter, according to some B theory description about that event, but you can't have any cognizance of it, no evidence about it that fixes it can reach you as of here. You're saying that it really is, in reality, open, as of this point, though. So we're relativizing to points. In reality, it's not, there's no fact of the matter about how things are here, as of this point. So it's a combination of ontological probabilism and this essential relativization of truth to points. And that's basically the view that I'm seeing as Stein being committed to, and that I can't make sense of this combination otherwise. So in particular, if you're this view, how things are as of this point and how things are full stop is deeply unattractive for reasons I've said something about. Namely, it is privileging this point in a way that's unproblematic. That's problematic. It's only unproblematic if you say, well, it's fine for this guy to be privileged because we're asking about what's true as of his location. That seems okay. But if you thought that what was true as of that location connected to some B-theory view, some monadic truth about the world, then you would, on the standard B-theory view, be denying that there's, in reality, it's open. It may be open epistemically as of this point, but in reality there will be a fact of the matter, it's either one way or the other here. Unless you interpret branching spacetimes in a particular way. So, can I go on for 3 more minutes?
Yeah.
Yeah. So branching spacetimes is a framework that generalizes standard branching time models in a particular way that's meant to look relativistic. So on standard branching time models, you're modeling the open future by having a tree-like structure where the nodes are instants, and you're considering, various truths, non-tensed truths holding at these points, and then you're giving rules for what tense truths are true at that point in terms of what's true at the past and what's true in the future. But because you've got branching, you can have that it's genuinely neither true nor false as of this point that there will be a sea battle tomorrow, because at this node there is a sea battle and at that node there isn't. But these nodes are global instants. That's the standard branching time way of modeling things. So what Belknap does, and histories in this model are just maximal chains through these branching structures. What Belknap does is replace these instants with points that correspond to basically space-time points. Then your chains correspond to time-like world lines, and you have given certain postulates where of identifying a history as a maximal upward-directed subset of this whole set of collection of possible space-time points related by causal relations. And this gives you a way of histories being kind of... So a nice way of thinking about these models is they're just a collection of histories, but their pattern of overlap is distinctively relativistic. So when we have the non-relativistic branching time structure, any two histories, any three histories that overlap are such that the overlap of 2 is contained in the overlap of, so A, B, C. So if I've got 3 overlapping histories, then the overlap of AB is contained in the overlap of BC in this case, and it's always going to be something like that for these non-relativistic branching structures. When you have the branching spacetimes, they can be overlapping in distinctively relativistic ways. So, in particular, I could have 3 histories, one, right, so there's a region of common overlap, but their region of common overlap, so what do I want to say? It's not the case that okay, so there are events here which overlap A and B, this event overlaps B and C, but the event that overlaps A and B isn't in C, and the event that overlaps A and C isn't in B. That's the kind of thing you can get. So basically you've got a formal theory that has a bunch of histories overlapping in this way, and one option, if you're a B theorist, is to just say, well, here's a way of having ontological probabilism compatible with this view. Just take this as a description of absolute reality. Now, so it's what you might get if you interpret quantum mechanics according to the Everettian interpretation, for example. As we've seen, so it's not obvious that defending objective probabilism by itself is incompatible with this view, but it doesn't seem that that's what Stein has in mind at all, of course. It seems much more likely that what he has in mind is that, well, as of a particular point, there are facts of the matter about everything in this region being determinate and everything in various things in this region not being determinate. And as of this region, there are other determinate facts, and you can get exactly that pattern of determinate facts by picking a particular history from this collection and then using that history, considering each space-time location from that history, and then using this branching model to read off the facts. And then what you get is a collection of facts about space-time that are temporally relative, but for which there's no kind of super view from no-when description of it that they correspond to. Okay, and I take it that what we've seen is that is seems very consonant with the kind of view that Stein was seeking to say was compatible with relativity. Okay, causal set theory. I think I'm out of time, so I'm not going to talk about that. But basically, the idea is sorry, hence reductionism, relative truth. Put it there. Right. So this is basically a relativistic version of the graph. But yeah. So okay. Thank you.